Each day, we generate millions of tons of sewage. Some is treated here in the Stonecutters Island sewage treatment plant. After the sludge is removed, the wastewater looks like this. Disinfectant is added before it's discharged into the sea. Just how this wastewater should be discharged to reduce pollution in Victoria Harbour is the problem Professor Joseph Lee and his team aimed to solve during the past 30 years. They applied the buoyant jet theory to the wastewater disposal systems on the seabed. And they developed a virtual reality modeling system called VizJet to show the evolution and interaction of multiple buoyant jet discharges. The wastewater is discharged through rosette jet groups to mix well with the ocean current so that it's highly diluted and prevents wastewater from flowing to the surface.
So as it comes out, because of the mixing we create, we engineer it to occur, then it becomes very much like seawater because it's mixed 100 times with the seawater. So the wastewater, by so doing, by this rosette group, it will stay submerged below the surface. And that means it's away from the beaches, it's sufficiently, you don't see it on the surface. And also by the time it comes to the beach, the concentration would have reduced to very safe levels.
Another advantage of using the rosette jet groups is they occupy less space and save construction costs.
Traditional designs is by means of risers, what we call linear risers. So you may have hundreds of risers and hundreds of jets. And that's very costly because it costs millions of dollars to do even one riser. Now with a rosette, you can greatly reduce the number of risers needed. So instead of one jet per riser, you can have 8 to 12 jets per riser. And hence you can reduce the construction cost and the operation and maintenance cost tremendously.
Their research applications won the second-class award in the 2010 State Science and Technology Awards. This award is conferred on scientific researchers who've made outstanding contributions in technology or public welfare projects. More than 680 entries competed for this award.
Certainly I'm very honored. I guess my colleagues, my students, there is a recognition of their work as well as our work over the years. As you know, China is a big country, a lot of water problems, and to get an award in the area of water, I feel very proud our work being recognized.
The team's buoyant jet theory was also applied in the Yuen Long Bypass Floodway project. A unique hydraulic jet river junction design increases the water flow to prevent flooding during heavy rain.
This application can lower the water level of upstream rivers by more than 1 meter. Without the need to extend a drainage channel, it now has the capacity to manage the level of flood water expected to be equaled or exceeded every 10 years to the level expected once every 15 years.
The theory also explained the SARS outbreak in Amoy Gardens in 2003. Droplets containing the SARS virus were dispersed upwards from the bathrooms due to the buoyancy effect. The World Health Organization recognized these findings. They applied these findings to enhancing hospital isolation wards' ventilation. They found putting the exhaust on the ceiling was more effective than the traditional floor-level design.
We work together with the medical community to understand what is the best way to remove the respiratory generated droplets from the room as fast, as quickly as possible, and as well as to reduce deposition of those droplets on surfaces in the room, such as bed and the floor.
Professor Lee and his team of local and mainland experts plan to continue their collaboration and hope to establish a center for hydraulics research to contribute towards solving pressing national issues.